definitions of all the time domain specifications. Now we will see the expressions for all the time domain specifications. We'll see the derivations. So the first one is unit step response of second order system. Underdamped case is given by, so we are going to derive now rise time, that is TR. So we have to consider here unit step response of second order system for underdamped case. So that expression we know we derive, so that is C of t is equal to 1 minus e to the power minus zeta omega n t divided by square root of 1 minus zeta square sine of omega dt plus theta. We know what is omega d, what is zeta, and what is omega n we know. So now we are going to find out the expression for rise time TR. So we have to change the expression or notation from T to TR at rise time. So at T is equal to TR, C of T is equal to C of TR, and it is equal to 1. From the diagram, time domain specification diagram, in that we can see at rise time TR, the output will reach to the 100% of the final value. So it will reach to the 100% in the sense we have taken the value as 1 there. So that's why at this rise time TR, the output C of t is equal to 1. So therefore C of TR is equal to 1 minus e to the power minus zeta omega n TR divided by square root of 1 minus zeta square sine of omega d TR plus theta is equal to 1. So now I can cancel here 1, left hand side and the right hand side is also 1, so I can cancel that one. So we get it minus e to the power minus zeta omega n TR divided by square root of 1 minus zeta square sine of omega d TR plus theta is equal to 0. Now since minus e to the power minus zeta omega n TR divided by square root of 1 minus zeta square is not equal to 0, we cannot equate that term to 0. So we can equate the sine term to 0. So sine of omega d TR plus theta is equal to 0. So if I call that sine of phi, that omega d TR plus theta as a phi, then I can write sine of phi is equal to 0, where phi is equal to 0, pi or 2 pi or 4 pi and so on up to n pi. So when sine function will be 0 when the value of phi is equal to 0, pi or 2 pi or 3 pi, 4 pi and all. So now here phi is equal to omega d TR plus theta we have taken. So I will change this phi to pi. When it is equal to pi, then the value is equal to 0. Pi is equal to omega d TR plus theta. So rearrange, because we want the value of TR. So rearrange the expression, we will get TR is equal to pi minus theta divided by omega d. So this is the expression. And now I don't want to keep this expression in terms of theta here. I want to change that theta to zeta and omega n or omega d. So that's why I have to consider right angle triangle. So with zeta and square root of 1 minus zeta square. And also we know that here omega d is omega n square root of 1 minus zeta square. So now from this triangle I can write tan theta is equal to square root of 1 minus zeta square divided by zeta. So if I substitute this theta in the above equation, so then I will get TR is equal to pi minus tan inverse of square root of 1 minus zeta square divided by zeta whole divided by omega d. So this is the expression for rise time. So next we will see an approximation expression for delay time TD. There's no derivation for this, it's not there for your syllabus, and the final expression is TD is equal to 1.1 plus 0.125 zeta plus 0.469 zeta square divided by omega n, where zeta is 0 to 1. So you have to remember this expression, you will get a problem on this. Next expression or derivation is peak time. So I'll derive this derivation for peak time in the next video. Thank you.